Hello from the Forcetronics YouTube channel. Welcome to using the KY-040 rotary encoder to control a TFT or thin film transistor display using the TFT eSPI library. And you can see the setup we're going to use right there in the picture. Before I get started, I'll just mention please support Forcetronics on Patreon, where you can find exclusive content, including the code from this video. If you haven't already, please subscribe to the Forcetronics YouTube channel. And if you like what you see here, please hit the thumbs up. All right, let's get started. Okay, in this video, we're mainly going to look at Arduino code, and the code is going to be about how to use this rotary encoder with a thin film transistor display or TFT display, and we're going to be using the popular and awesome TFT eSPI open source library. So we'll use the encoder to control and navigate the display and change settings. And you'll get to see basic examples on how to navigate text, draw text, erase text, same with numbers, same with shapes. And we'll also use a round meter or a arc meter in our demo to draw the meter you can see in the bottom right corner. And this library has a lot of capabilities, but this video is basically going to show some of the more basic ones. But there's a lot of things this library can do, and that's one of the things that makes it great. Now, the encoder part, I'm going to use an encoder class that I covered in another video. So I'm not going to go over that code in detail. So if you want to see the code from the encoder class in detail, check out my video developing Arduino control software for the KY-040 rotary encoder. And we're going to be using the exact same code from that video. Okay, here's some information on our setup, and then we'll dive into a demo, and then we'll spend the rest of most of the video going over the code. So I use the ESP32 room board, but this should work with other Arduino supported devices. I didn't test it with any other ones. The TFT eSPI library does recommend, though, you use a pretty high performance microcontroller for it. And I think they recommend a 32-bit, which the ESP32 is a 32-bit microcontroller. So I tested this on a TFT display that uses the ILI 9341 driver, which seems to be the more popular one out there. This will probably work with other display drivers that the library supports, but I didn't test those. And this video assumes that you know how to use the library, how to get started. This library is a little different than a lot of other ones, so you got to change that user select.h file. If this is all new to you, or if you never used this library before, I do have a video on getting started with the TFT eSPI library using the Arduino IDE. I'm going to assume, though, you know how to use the library in this video. You can see the version of the library I'm using at the time of this video. You'll be able to access all the content from this video, the code, on my Patreon page. Okay, let's start by seeing an example of the hardware and the software, what we're going to focus on in action. Before I dive into the video, I should mention the context of the video. So I made this screen because I have an indoor automated gardening setup, and I want to be able to control my different LED wavelengths for different stages of the plant's growth. And so that's why I have this white, blue, red, and F red stands for far red. And so this will allow me to control the LED wavelength intensity for the different spectrums that my lights can put out. So that's the context of why I created this. Of course, you can take this code and modify it however you want to use it, but I just wanted to let you know what my context was. So here is the screen. You can see we can navigate the different menus. So with the encoder, you can't see me turning the encoder, but I'm turning it clockwise and counterclockwise, and it allows us to select the white, blue, red, and far red settings. And then the intensity goes from 0 to 100. So you can see I have white at 85, and then so on and so forth as I go to blue. Now, I just pressed the encoder button. So I selected blue, pressed the button. That allows me then to edit this percentage with the encoder, and I already started doing it. So you can kind of see me editing with the encoder. I'm turning the encoder up or clockwise. I then press the button to set it. I then go to far red, and now I'm turning the encoder in the opposite direction, so the menu can roll over. So I rolled over from 5% to 95%. I press the button to save the setting, and then I'm just kind of showing you how I can easily navigate through the menus. So all that is done with the encoder, right? And that's what's great about this encoder. It not only can turn either direction, but it has that button. So it's a great low cost, easy, low space way to create a device where you can navigate a menu. Some of these displays have touch capabilities. I didn't want to deal with touch capability just because in my garden setup, it's sort of the screen's really covered because I don't want it to get wet or anything. So in this context, I'm just using the rotary encoder to control the screen. And now that we've seen the screen and the rotary encoder and our whole setup in action, let's review the code. And so here I'm on the main sketch, but we have two classes here. We have the encoder class, which is what I covered in another video, and I didn't really change anything in there. I'll just briefly show that class in this video, but once again, I have another video and I'll have a link in the description section to access it. The main class we're going to spend the time in is the display handler, which is essentially a wrapper for the TFT eSpy library. And then I have my definitions.h is just that's where I store all my constant values, my defined values. So let's start on the main part of the sketch. We'll run through that and then we'll do a deep dive into the display handler class. So first I'm going to include my two classes and my definitions.h files. I then declare objects for each of the classes. My main global variable besides the objects is this structure of settings. So if you remember, we have the white, blue, red, and far red, and we can change the value, and the value corresponds to the percentage that you saw on the screen. So this Boolean character is if we're actively adjusting a setting, that Boolean will be set to true. And if we're not actively adjusting a setting, it'll be false. And that lets our encoder know what it's changing, whether it's moving that square or rectangle around the menu, or if it's actively changing a value. And then, of course, the value itself is stored in the other variable in the structure, the set value. And since we only go from 0 to 100, we can use a pretty small unsigned integer for that. And then I declare an array of the structures, right? Because we got to hold the information for white, blue, red, and far red. So this constant is a value of 3, and I just add 1 so that there's 4 items. First thing we do is we initiate our encoder class. And this fred is just saying what the max encoder value is before it rolls over. So if you saw the encoder video, my encoder class is made to navigate a menu, right? So by setting that to fred, it tells the encoder whether you're moving clockwise or counterclockwise, there's only 4 positions, 0 to 3. And every time you get to 0, it rolls over to 3. And if you get to 3, it rolls over to 0. And we can change that in real time depending on whether we're adjusting the menu or adjusting a value. And then we have our pins, and these are defined in the definitions.h file, but these are just the pins from the ESP32 that are connected to the encoder. Here is the settings structures and the arrays, and all I'm doing here is setting them to initial values. So I set each one to 10% to start out with, and neither of them are being adjusted when it first starts, so I set that all to false. The encoder, I'm setting the values or the default starting value of the encoder. So the encoder is being told to be at 0, which means the white selection in the menu, if you remember the menu. And I defined a previous encoder count too. And the previous one is important too. When you're changing that rectangle around, we want to be able to erase the old rectangle. That's why we have to know what the previous one was before we draw the next one. So that's why keeping track of those is important. And then I call my display init display handler, and this is going to set up the display. And I want to know what the encoder count is to know where that square should be around which color. And then I want to display the initial value for that white menu, and that's going to be 10%, right? So that's going to set the arc meter as well as the value shown on the screen. So that's just the setup file. And then our loop's pretty simple, and it's the encoder. The way I use the encoder in the encoder class, which you should remember, is it's interrupt driven. So I have two big if statements in here. This first one is for the encoder position change. So that function will return a flag that's true whenever the encoder is turned either clockwise or counterclockwise. So an interrupt will occur, it sets a flag to true, and the main loop will detect that that flag's true. Once we enter this if statement, it resets the flag for us. And then our menu sort of works in, our display, our settings menu sort of works in two different modes. There's the mode where we're navigating the different menu items, white, blue, red, far red, and then when we're actively adjusting the value for one of those. And so if value adjust active is true, that means we're actively changing one of the values from 0 to 100%. And so this uses the display handler to update the setting value. So if we turned it clockwise, it turned the value up 1%, or if we did counterclockwise, it turned it down 1%. And then it also updates the menu. right? So this is if we're actively adjusting a value. If we're not and we're just navigating the menu, this else statement is true. And so this is going to draw menu selection, which basically changes the position of that rectangle for selecting the different settings, right? And that function not only chooses the next one, it erases the old one. We also want to display what is the setting for whatever color we have selected. So that's what these functions are called for, because we won't be able to adjust them. They won't get adjusted, but we'll show that arc menu and that value for that menu item. So these are what's called if we move the encoder. And here's what happens if we press the button. So the button's important because it allows us to select a setting. And once we select a setting, whether that's white or blue or red or far red, we can then adjust the value. And then once we're done adjusting the value, if we press the button again, that saves the value and goes back to the settings selection. So if we're actively adjusting a value, thing we called in the previous interrupt routine, so if this is true, that means we've adjusted our value to what we want it to be, and we're going back to the settings selection mode. So here we get what setting we're adjusting. We then set that to non-active because we're done adjusting it. We then save the value, which is stored in the encoder count. So, maybe we went from 25% to 35%. That'll be stored here. We then reset our rotary encoder count because we're going back to the menu selection. We set our previous and our current encoder count, which is whatever selection we are adjusting. And then we update the text on the bottom of the screen to the default value. If we're not actively adjusting something and we press the button, this else statement is true. And so now we're entering the mode where we do adjust a value. So first we want to know what position on the settings menu we are, white, blue, far red, red. So we get that. We then set that menu item active, meaning we're going to adjust it. And here's where we change the encoder count, right? So we're adjusting a value. So we want the encoder to be able to go from 0 to 100. So that's where we set this. Then we get the current encoder count and the value. I shouldn't say current encoder count. I should mean the previous set value, and we plug that into an encoder. So wherever the encoder is, that's what the count is in software. Maybe it's 25%, maybe it's 35%, 45%. And then, of course, we make sure we draw those values. Chances are they're already drawn on the screen, but we put these here just in case. So that's pretty simple how we're using the main sketch. And then we have these functions down here, which we use in the main sketch, which is basically returning a non-zero for which one is active, right? So if none of them are active, this will return false. And this is the function you see up there in the if statements. If none of them are active, this will return false. If one of them is active, it'll return a non-zero number. And the reason I return the actual count is so I can know what setting is active. And white is 0, so that's why I'm adding 1. So I know to just subtract 1 if it's a non-zero. And then these functions just set one of the menu items to active or to non-active. Okay, here we are at the encoder class, and I didn't change this from my other video. The only thing I did change, so I guess I did change something, is some of these global variables, I changed their default state to match what I want to do in the code. But the code itself, the function calls and stuff, I didn't change. Here are the interrupts that are firing. If the encoder is turned, this interrupt fires and sets the different encoder numbers and directions and things like that. And then if this one fires, we just get a flag that's set to true to know that the button was pressed. So in the main loop, that's where those interrupt flags are getting set to know if one of those if statements should be true. Here is the display handler class, and I'm showing the .h first. So you can see all of our functions in here are public functions, and then all of our variables are private. And of course, you can change this around to however you want to do it. But if we go into the .cpp file, we, of course, are calling the TFT eSpy library. You also have to call the SPY library. I'm calling my definitions.h so I can access my constants. And of course, I'm calling the .h for this class. And you can see first we do the constructor. This init display actually calls multiple functions, but this is just setting up the display initially. Now, if your display has an LED pin or a display enable or disable pin, that's what I'm setting here. So not all displays have this, and this is not set up in the library. So what I'm doing is I'm manually setting this pin to enable my display. Your display may or may not have this pin. I then do a TFT init. I then set the rotation to 1, which is a landscape type rotation. I set the background to black. And then in some of my global variables, I store screen positions that I use a lot. And that's one of the trickiest things for me, at least when I first started using this library, was understanding how to put shapes or numbers or things exactly where I want them on the display, and then how to eventually erase them and things like that. So I want to have X size and Y size. This is actually the center of the display. That's where I write my value and my round or arc meter. So I put those in the globals because I use those over and over, and I don't want to have to keep calling this. And then X menu is for the menu items at the top. I divide the X axis into 5 equal chunks. And then what I do is I use that to space out my 4 menu items. This sets up the text for the menu and the bottom text that you see on the bottom of the display. This sets up the arc meter and draws the initial with the default values. This inits the setting value, which is the percentage value you see in the middle of the arc meter. So these are all functions, and they're right here. So this is, once again, drawing the menu text, draw the selection. So this is just writing the constant white, blue, red, far red. This is drawing the box around the initial setting, which in our case was white, and this sets the bottom text. This initiates the arc meter, and this code for setting up the radius of the arc meter I actually got from an example sketch from the library. So I did not write this myself, so to make that clear. I then draw the border of the arc meter, which I only need to draw once because I never erase it. So I'm just setting up that round border, and then I'm setting up the initial setting of the arc meter. Then this code is going to set up the initial value displayed in the arc meter. I should say the number value in the arc meter, as well as the percentage sign. So for placing text or numbers, this set text datum is important, right? So this is a constant from the library, and this basically stands for MC, stands for middle center. So it's almost like writing text or numbers in the middle and having them center aligned. And that's important because you want to know how to erase them later or how they're going to appear on the screen. Then I set the padding. The padding's important because it tells it how much digits or characters will be in that space. So if you change it, it'll erase it for you. You don't have to manage erasing the old numbers or text and writing the new ones. So here is where I put that percentage sign. And, I do have some custom positioning in there to put it to the bottom of the percentage number itself. And then I write the percentage number itself. And notice I use 2 different fonts. So this is font number 4, and this is font number 6. And my padding is bigger because I can have up to 3 numbers at 100%. So here, this function is just a wrapper for drawing the number in the middle of the arc display. And so I just wrap that up. This X size and Y size, you saw me set that earlier. The font value. So the only argument for this function is the actual percentage value, which is being changed by the encoder. This is for updating the arc meter. Now, some of this code in this function, I changed it around a little bit, but a lot of it came from the example file from the library. So I appreciate those folks who wrote that. I'm mapping my 0 to 100 to the arc, and a circle is 360 degrees. So I'm starting at 30 and I go up to 330. So there's 60 degrees at the bottom that the meter doesn't cover, but that's just mapping the percentage to the meter itself. This if statement is if I'm drawing a new meter, like if I'm going from one color to the next, I want to make sure I erase the old one. And then this if and else statement is if I'm adjusting an existing meter, instead of drawing the color over and over again, the full color or the full meter, I detect if I went higher or lower, and I just add some color or make the meter slightly larger, or I add black to erase part of the meter. So that's supposed to just save time. And that's why I'm saving the previous arc, so I can do that and save a little bit of time. But if we're drawing it from scratch, we use this clear arc. This function was called in the init, and this is just setting up the initial meter and draws the circle. And once again, that never gets erased. It's only drawn once. This display handler is going to show the menu text. So notice I'm using that middle center datum again. I'm setting the text color. And then I have as a string, a constant, this white string and then a blue string. So those are just constants. I'm using that X menu positioning. I do a little bit of adjusting just based on the eyeball test. So I kind of move white and far red a little over more to the side. I thought it looked better. These are constants. This is just a constant for the y-axis where I want them to appear. Then, of course, the font setting. And then X menu was divided by 5. So here this is times 1, times 2, times 3, and times 4. So that's how we're setting up the menu items. And they never get erased either, right? So we just move this selection rectangle around them. So that's what we look at next. So this is for drawing that selection rectangle. Whenever we change it with the encoder, this function's called. And so what happens is the first thing we do is we erase the existing one. So first we detect where the previous one was, and we use the previous encoder count to do that. And notice we're drawing it as black. So that basically draws over the old white one so it disappears. And then we draw the new one in white right here. This function is just handling the bottom text. And so what happens is if you're moving through the settings menu and you press the button, the bottom text will tell you which color you're adjusting, white, blue, red, far red. And then once we exit, the adjustment mode and go to the menu select mode, we just draw this LED wavelength intensity. And then finally, this last function is telling the arc meter what color we're using. So based on the menu item we have selected or the settings item we have selected determines the color, and we tell the arc meter, hey, use red, use blue, use dark red. And by the way, dark red is a custom color that I have defined in the definitions folder. These other colors are standard colors in the library. And finally, here is the definitions file. I won't go too much in it. I mentioned this in my other video, but basically to create a custom color, they use an unsigned 16-bit integer, and 3 RGB colors are actually 3 bytes instead of 2. So this is a method they use to compress the value into a 16-bit int. But the RGB number is hidden in here. It's 120, 15, and 15. So you can kind of go through this on your own. But these are the constant values I'm using. Okay, that's it for using the KY-040 rotary encoder to control a TFT display using the TFT eSpy library. If you have any questions, please use the comment sections. And if there's anything I missed or anything you want to add, because this is a pretty comprehensive library, please do. Thank you for watching.